Hi everyone, today I'm going to talk to you about organic nomenclature. We're going to do a simple version of this. Organic nomenclature can get quite complex, but we're just trying to give you enough information so you can do the pre-lab to your evaporation lab. So organic chemistry is a branch of chemistry that's completely based around the atom carbon. Carbon is unique in that it can form 4 single bonds, and as a result, it can form all sorts of really complex molecules. So there's an entire branch of chemistry based just around carbon, again called organic chemistry, and it has its own system of naming or its own system of nomenclature. Which is a little frustrating for folks. So the way that we name organic compounds, the first thing we do is we figure out how many carbons are in the longest chain of carbons for that molecule. And so if there's only one carbon, the prefix we use is meth. You probably remember the compound methane. Methane is CH4, it's one carbon. If there are 2 carbons, then the prefix is eth. You probably remember ethanol. That's an alcohol that we used in a lab. If there are 3 carbons in the chain, the prefix is prop, like as in propane tanks on grills and things like that. The next one is 4 carbons. The prefix is bute. I know that looks like but bute is the prefix, like butane lighters. I'm not going to go through all of these. I would recommend you pausing and writing down the rest of them. The rest of the prefixes, though, seem a little more logical than those beginning ones. So the first type of organic compound we're going to learn how to name is an alkane. Alkanes are organic compounds that only have single bonds between the carbons. Now you may be asking, well, what if there's more than single bonds? What if there's double or triple bonds? There are definitely ways to name those molecules, but we're going to stick with the very simplest for right now. And if you want to talk about it, I would be happy to chat with you about double and triple bond compounds. So alkanes, here's an example of an alkane. Notice we've got 2 carbons that are bonded to each other. There's a single bond in between them. So if it were not a single bond in between those carbons, then we would have to use a different system. But this is going to be an alkane. So the first thing you're going to want to do is you're going to want to figure out, if you're going to name this, the number of carbons. And the reason you want to know the number of carbons is to determine the prefix. Now, we just learned on the previous slide that if you have 2 carbons, like right here, if you have 2 carbons, then what is the prefix? That's right, eth. All right. So in this case, our prefix would be eth, and then we're going to add the suffix, the ending ane, to the prefix eth. And so this molecule right here would be called ethane. Ethane. All right, so let's try some more examples. Take a look at this one, methane. See if you can figure out what it would look like. You may have known this one already since we've talked about methane before, but did it look like this? You've got 1 carbon because of the prefix meth. Now, you know, there aren't any other carbons for it to bond to, so it would have to be methane. There's no other, you know, you can't have a double or a triple bond because there actually aren't any other carbons to bond to. But remember, carbon can form 4 single bonds, and so in addition to that carbon right there, then it would have 4 hydrogens attached to it because of the octet rule. All right, let's go backwards. Let's take this compound right here and figure out what its name is. So we've got 1, 2, 3 carbons in our chain. What's the prefix for 3? That's right, prop. And notice there's only single bonds between the carbons. We've got hydrogens attached to all the carbons, so you notice that all of the carbons have 4 lines coming from them, 4 single bonds from them. So if the octet rule is not being satisfied by bonding to another carbon, it will be satisfied by bonding to a hydrogen. So we decided that the prefix here was prop, and it's all single bonds, so that molecule would be called propane. All right, now we're going to get just a tiny bit more challenging with alcohols, because we're going to use alcohols in the lab as well. So an alcohol is an organic compound that has an hydroxyl group attached to it. Now, hydroxyl group is going to look a lot like hydroxide, the polyatomic ion, but it is not an ion. It's actually covalently bonded to the molecule. So it's actually going to be an oxygen bonded to a carbon, and then the oxygen is going to have room for something else to attach to it, and it's going to be a hydrogen. So with an alcohol, here's an example right here. What do you think we're going to have to figure out first before we can finish naming it? Yeah, we're going to have to figure out how many carbons we've got, right? So 1, 2, 3, 4, 5 carbons. The prefix for 5 carbons is, that's right, pent. All right, so to name an alcohol, just like with an alkane, you're going to count your number of carbons to determine your prefix. So we just said pent. And then notice it has an OH group attached to it. That OH group is your hydroxyl group, and so that makes it an alcohol. Alcohols' names end in anol. So that's going to be pentanol. Pent for the 5 carbons, anol for the hydroxyl group attached. All right, try these. See if you can draw heptanol. Pause the video if you need to. Heptanol with the prefix hept is going to have 7 carbons. So you're going to have 7 carbons in a chain. And then anol, that's going to be a hydroxyl group attached to one of those carbons. And there's ways to know which carbon to attach it to and all that kind of stuff, but we're just going to attach it to an end carbon for right now. So it's going to look like this. But if you had put the OH on this end, that would have been fine. Or honestly, in the place of any of these hydrogens, that would have been fine. All right, now see if you can name this alcohol. Pause the video if you need to. We're going to count up our carbons. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh my gosh, what's the prefix for 9? Non. Notice there's all single bonds between my carbons, and I've got a hydroxyl group on the end. So that's going to be called nonanol, which is kind of fun to say. Nonanol. All right, so what you're going to do now is you're going to attempt, give it your very best effort, to do the pre-lab for the evaporation and intermolecular forces attractions lab. It might be easier to do the structural formulas first, like actually draw out your carbons and your hydrogens and all that, and then go back and do the chemical formulas. It's your call. And then after you've done that, what you're going to need to do is to determine which molecules are going to evaporate the fastest. That's the final column in the top data table. What I would urge you to do when you're making that prediction or making those predictions is to think about what types of intermolecular forces a molecule has and how many it has. That's going to be helpful in making a good prediction. Good luck.